NASA's Artemis program is set to revolutionize lunar exploration as it embarks on a mission to return humans to the moon, marking the first crewed lunar landing in over 50 years. The Artemis campaign aims to establish a sustainable human presence on the moon and lay the groundwork for future missions to Mars. The program is characterized by its commitment to inclusivity, scientific discovery, and technological advancement. Objectives and goals. The Artemis missions are designed with several key objectives. Scientific discovery. The moon serves as a 4.5 billion-year-old time capsule offering crucial insights into the solar system's history. NASA plans to explore regions rich in resources, particularly near the lunar South Pole, which is believed to contain water ice and other materials critical for sustaining human life. Technology advancement. The program will advance technologies necessary for lunar exploration and future Mars missions. This includes the development of new spacesuits, lunar rovers, and systems to utilize lunar resources. Sustainable human presence. By establishing a long-term presence on the moon, NASA aims to conduct extensive scientific research and support the next generation of space explorers. The Artemis 3 mission is particularly notable for its goal of landing the first woman and the first person of color on the moon. Scientific and technological exploration. NASA emphasizes the moon's potential for scientific exploration, referring to it as a time capsule that can unlock secrets about Earth's formation and the evolution of the solar system. Future missions will extend the range of lunar exploration, with Artemis 3 targeting the moon's south pole and surrounding regions. This area is of particular interest due to the presence of water ice, which could be used for life support and fuel for deep space missions. Technological advancements are central to the Artemis program. The development of the Lunar Gateway, a space station that will orbit the moon, will facilitate crewed missions and serve as a staging ground for lunar landings. Additionally, NASA is working on advanced lunar rovers and habitats to support astronauts during their time on the moon. International collaboration. The Artemis program is not a solitary endeavor. It includes strong international cooperation through the Artemis Accords, which have been signed by 50 countries. This framework promotes peaceful collaboration in space exploration, emphasizing safety, transparency, and shared benefits. By fostering partnerships with both international space agencies and commercial entities, NASA aims to create a collaborative environment that enhances the exploration of the moon and beyond. Timeline of key events. The Artemis program has already made significant strides. November 16, 2022, Artemis I successfully completed an uncrewed test flight around the moon, demonstrating the capabilities of the Space Launch System (SLS) and the Orion spacecraft. 2024, Artemis II is scheduled as the first crewed flight testing the Orion spacecraft in lunar orbit. 2025, Artemis III aims to land astronauts on the lunar South Pole, marking a historic return for human exploration. Habitat and living conditions. NASA is also focused on creating sustainable living conditions for astronauts on the moon. The development of habitation systems, including those for the Lunar Gateway and surface habitats, will ensure that astronauts can live and work effectively in the harsh lunar environment. Simulated missions are being conducted to prepare for the challenges of living on the moon, such as radiation exposure and resource utilization. Future missions and goals. Beyond Artemis III, NASA envisions a series of missions that will continue to explore the moon and use its resources to prepare for Mars. The program will pave the way for future crewed missions to the Red Planet, demonstrating technologies and systems necessary for long-duration space travel. Conclusion. NASA's Artemis program represents a comprehensive strategy for lunar exploration that emphasizes scientific discovery, international collaboration, and technological innovation. By returning humans to the moon and establishing a sustainable presence, NASA not only aims to enhance our understanding of the solar system but also to inspire future generations of explorers. The Artemis missions are poised to redefine humanity's relationship with space, demonstrating a commitment to exploration that is inclusive, cooperative, and forward-looking. NASA's Artemis program represents a multifaceted approach to lunar exploration and aims to establish a sustainable human presence on the Moon. Here are some counterintuitive points regarding this initiative. 1. Focus on diversity and inclusion. While space exploration has historically been dominated by male astronauts, the Artemis program explicitly aims to land the first woman and the first person of color on the lunar surface. This commitment to diversity in astronaut selection is not just a symbolic gesture, it underscores a broader strategy to engage a global audience in space exploration, which is often perceived as a domain for elite scientists and engineers. 2. The Moon as a resource hub. Contrary to the traditional view of the Moon as merely a celestial body for exploration, NASA now regards it as a potential resource hub. The focus on utilizing lunar resources such as water ice for sustaining human life and facilitating travel to Mars is a shift from earlier missions that primarily aimed for scientific discovery. This practical approach suggests that the Moon could serve as a stepping stone for deeper space exploration, challenging the perception that lunar missions are standalone endeavors. 3. International collaboration versus competition. The Artemis program emphasizes international collaboration through the Artemis Accords, which have been signed by 50 countries. This is counterintuitive, as space exploration is often viewed as a competitive arena, particularly in the context of the Cold War. The collaborative framework aims to promote peaceful cooperation and shared benefits, suggesting a paradigm shift in how nations approach space endeavors. 4. Technological leap versus incremental progress. The development of advanced technologies for lunar exploration may seem like a continuation of past efforts, yet the Artemis program is taking a significant leap forward. The introduction of new systems like the Lunar Gateway, which will facilitate crewed missions and lunar habitation, reflects a more integrated approach to space exploration. This moves away from the incremental progress seen in earlier missions and instead proposes a comprehensive infrastructure for sustained human presence on the Moon. 5. The Moon as a scientific laboratory. The Moon is often viewed merely as a destination for human exploration. However, NASA portrays it as a 4.5 billion-year-old time capsule that can provide insights into the solar system's history. This dual role as both a destination and a laboratory for scientific discovery challenges the notion that missions are solely about human presence. They also significantly contribute to our understanding of planetary formation and evolution. 6. Sustainability versus short-term goals. Historically, lunar missions were often short-lived, with specific objectives that focused on immediate scientific gains. In contrast, the Artemis program's long-term vision emphasizes sustainability and infrastructure development. This shift suggests that future missions will not only seek to gather data but will also lay the groundwork for ongoing exploration and habitation, which was not a focus of earlier programs. 7. Public engagement and education. The Artemis program aims to inspire the next generation of explorers, which is not a new goal for NASA, but the methods for achieving it are evolving. The program actively seeks to engage the public through educational initiatives and partnerships with commercial entities, suggesting that space exploration is becoming more democratized. This contrasts with the historical view that space missions are the exclusive purview of government agencies and elite scientists. 8. Commercial partnerships. Rather than solely relying on government funding and expertise, NASA is partnering with commercial entities to achieve its goals. This approach challenges the traditional view of space exploration as a government monopoly and reflects a broader trend toward privatization in the aerospace industry. Such collaborations could accelerate innovation and reduce costs, redefining the landscape of space exploration. 9. Lunar economy development. The idea of a lunar economy which encompasses commercial activities and resource utilization on the Moon challenges the conventional perspective that lunar missions are primarily scientific endeavors. By fostering a lunar economy, NASA is paving the way for sustainable exploration and potentially transforming how we view economic activity beyond Earth. 10. Simulations versus actual missions. While simulations have long been a part of mission preparation, the extent to which NASA relies on them for future missions is increasing. The use of analog missions to test technologies and strategies for Mars and Moon missions suggests a shift towards a more experimental and iterative approach to exploration. This contrasts with earlier missions that often relied heavily on theoretical planning without extensive real-world testing. In summary, NASA's Artemis program is not just about returning humans to the Moon. It represents a significant shift in philosophy regarding how we approach space exploration, emphasizing diversity, sustainability, collaboration, and economic development. These counterintuitive aspects challenge historical norms and suggest a more integrated and practical approach to exploring our celestial neighbors. NASA's Artemis program is an ambitious initiative that aims to return humans to the Moon, establishing a sustainable presence and paving the way for future missions to Mars. While the key elements of the program are often highlighted, such as the goals of scientific discovery, technology advancement, and international collaboration, certain significant aspects may be overlooked by the general public. Here are some of the most crucial but frequently neglected points along with their significance. 1. The importance of inclusivity in astronaut selection. One of the most noteworthy aspects of the Artemis program is its commitment to inclusivity in astronaut selection. Artemis 3 is set to land the first woman, first person of color, and first international partner astronaut on the lunar surface. This commitment reflects a broader societal shift towards diversity and representation in fields historically dominated by certain demographics. Significance. This inclusive approach goes beyond mere symbolism. It represents a significant cultural shift in space exploration. By ensuring that diverse voices and perspectives are included in the missions, NASA not only enriches scientific inquiry but also inspires young people from various backgrounds to pursue careers in STEM, science, technology, engineering, and mathematics. The visibility of underrepresented groups in such high-profile roles can motivate the next generation of explorers to envision themselves in similar positions. 2. Lunar resources and their strategic importance. The Artemis missions are not just about exploration, they also focus on the Moon's resources, particularly water ice, which has been identified as a critical element for sustaining human life during extended lunar missions. The potential for in-situ resource utilization (ISRU) could allow astronauts to produce oxygen, water, and even fuel from lunar materials. Significance. The strategic importance of lunar resources cannot be overstated. Establishing a capability to utilize these resources could significantly reduce the cost and complexity of long-duration space missions, including future missions to Mars. If NASA can demonstrate effective ISRU on the Moon, it could set a precedent for similar technologies on Mars and beyond, fundamentally changing the way humans explore space. 3. The role of the Lunar Gateway. The Lunar Gateway is a planned space station that will orbit the Moon, acting as a hub for crewed missions and a platform for scientific research. While it has been mentioned in various reports, the technical and operational implications of the Gateway often receive insufficient attention. Significance. The Gateway will facilitate international collaboration and commercial partnerships, serving as a staging point for lunar landings and a platform for deep space exploration. It will allow for continuous human presence in lunar orbit and support the Artemis missions by providing a base for astronauts to live and work. This infrastructure is critical for extending human presence in space and conducting missions to Mars, highlighting the interconnected nature of lunar and Martian exploration. 4. Analog missions and their preparatory role. NASA conducts analog missions, simulated missions designed to prepare for actual space exploration. These missions are essential for testing systems, training astronauts, and solving engineering challenges that will be faced during real missions to the Moon and Mars. Significance. While analog missions may seem like a secondary aspect of the program, they play a crucial role in risk mitigation. By identifying potential problems and solutions through simulations, NASA can significantly enhance the safety and efficacy of actual missions. This preparatory work can lead to innovations that improve life support systems, habitat designs, and operational protocols, ultimately making space travel more feasible and sustainable. 5. Lunar economy and commercial opportunities. The Artemis program is not solely a governmental endeavor. NASA is actively fostering a lunar economy through partnerships with commercial entities. This includes contracts for lunar landers, rovers, and other technologies, as well as initiatives like the Commercial Lunar Payload Services (CLPS) program. Significance: the development of a lunar economy can lead to new markets and job opportunities on Earth, stimulate technological advancements, and engage private companies in space exploration. By creating a framework in which commercial entities can thrive on the Moon, NASA is laying the groundwork for a sustainable future in space exploration that leverages both government and private sector capabilities. 6. The Artemis Accords and international cooperation. The Artemis Accords promote a framework for international collaboration in lunar exploration, emphasizing principles such as safety, transparency, and the peaceful use of outer space. While these accords are often mentioned, the broader implications of such international cooperation are frequently overlooked. Significance: establishing a cooperative international framework for lunar exploration is essential not just for scientific discovery but for geopolitical stability. As more nations and private entities engage in space activities, having a shared set of principles will help mitigate conflicts and encourage peaceful collaboration. This sets a precedent for future endeavors in space, fostering a spirit of cooperation that can extend to Mars and beyond. 7. Technological innovations for sustainable living. The Artemis program involves the development of advanced technologies for sustainable living on the Moon, including habitats, life support systems, and power generation methods. The focus on sustainability is often overshadowed by the excitement surrounding human landings and scientific discoveries. Significance: the technologies developed for sustainable living on the Moon will have far-reaching implications for future Mars missions and may even have applications on Earth. Innovations in resource management, energy production, and habitat construction can provide solutions to current challenges related to climate change and resource scarcity. Emphasizing a sustainable approach not only ensures the success of Artemis missions but also aligns with global priorities on Earth. 8. The concept of LunaNet. LunaNet is an initiative aimed at establishing a communication and navigation network on the Moon, which is crucial for the success of lunar missions. While its significance is often mentioned, the technical challenges and possibilities it entails are frequently overlooked. Significance: LunaNet will enable seamless communication and data sharing between various lunar missions, enhancing operational efficiency. This network can facilitate real-time scientific collaboration, improve navigation for rovers and astronauts, and support a variety of lunar activities. The establishment of such a network is essential for creating a robust infrastructure that can support long-term human presence and scientific exploration on the Moon. Conclusion: NASA's Artemis program represents a transformative leap in lunar exploration with implications that extend far beyond the Moon itself. While many aspects of the program are celebrated, the points highlighted above are often overlooked yet are critical to understanding the full scope and significance of Artemis. By recognizing the importance of inclusivity, resource utilization, international collaboration, and technological innovation, we can better appreciate how the Artemis missions are not just a return to the Moon but a bold step toward a sustainable future in space exploration. The four most valuable points for in-depth analysis and discussion regarding NASA's latest moon landing plan, specifically the Artemis program, are as follows. 1. Objectives and goals. The Artemis program has clearly defined objectives that extend beyond mere lunar exploration. It aims to establish a sustainable human presence on the Moon as a stepping stone for future Mars missions. This includes scientific discovery, technology advancement, and international collaboration. The commitment to landing the first woman and the first person of color on the Moon is a pivotal part of this initiative, reflecting a modern and inclusive approach to space exploration.
The implications of these goals are profound,
as they could redefine humanity's relationship with space and inspire a new generation of scientists and explorers. 2. Scientific and technological exploration.
The Moon is referred to as a 4.5 billion-year-old time capsule, and the Artemis missions are designed to unlock its secrets. The scientific exploration focuses on areas rich in resources, particularly near the lunar South Pole where water ice is believed to exist. The significance of this exploration lies in understanding the Moon's role in the solar system's history and the potential for using lunar resources to support long-duration human missions.
Technological advancements such as new spacesuits and lunar rovers are being developed to enhance the capabilities of astronauts on the lunar surface,
which will also benefit future Mars missions.
3. Infrastructure and technology development.
The Artemis program is not just about landing on the Moon, it is also about building the necessary infrastructure for sustainable exploration. This includes the Lunar Gateway, a space station that will orbit the Moon and serve as a hub for crewed missions and advanced habitats that will support astronauts on the Moon's surface. The development of lunar resource utilization technologies is critical as it will enable astronauts to produce essential supplies while on the Moon, thereby reducing the need to transport everything from Earth. This focus on infrastructure and technology is essential for achieving long-term goals in space exploration.
4. International collaboration.
The Artemis Accords signed by 50 countries signify a commitment to peaceful cooperation in space exploration.
This collaborative framework emphasizes safety, transparency, and shared benefits, highlighting the importance of international partnerships in achieving the ambitious goals of the Artemis program.
Analyzing the implications of such collaborations can provide insights into how global cooperation can enhance scientific discovery and technological advancement in space, as well as foster a spirit of unity in exploration efforts beyond Earth. These 4 points encapsulate the strategic, scientific, technological, and collaborative dimensions of NASA's Artemis program, providing a comprehensive framework for discussion on its implications for the future of space exploration.
1. Apollo 11, 1969.
Apollo 11 was the first crewed mission to land on the Moon, marking a historic achievement for NASA and humanity as astronauts Neil Armstrong and Buzz Aldrin set foot on the lunar surface on July 20, 1969.
This mission was a pivotal moment during the Cold War era, showcasing American technological prowess in the space race against the Soviet Union. The mission's success was a culmination of years of advancements in space technology and exploration, leading to profound scientific discoveries and inspirational achievements in human spaceflight. 2. Luna 9, 1966. Luna 9 was the first spacecraft to achieve a soft landing on the Moon and transmit photographic data back to Earth. Launched by the Soviet Union on January 31, 1966, Luna 9 successfully landed on February 3, 1966 and provided the first images of the lunar surface, significantly advancing our understanding of the Moon. This mission demonstrated the feasibility of soft landings on other celestial bodies and was a major step forward in lunar exploration, laying the groundwork for future missions including the Apollo program. 3. Chandrayaan-2, 2019.
Launched by the Indian Space Research Organisation ISRO on July 22, 2019, Chandrayaan-2 aimed to explore the lunar South Pole region.
The mission included an orbiter, lander, and rover,
seeking to enhance scientific knowledge of the Moon's surface and its mineral composition.
Although the lander Vikram lost communication during its descent, the orbiter continues to function and provides valuable data about the Moon's atmosphere and surface.
Chandrayaan-2 exemplifies the increasing global interest in lunar exploration and the role of emerging spacefaring nations in contributing to our understanding of the Moon. NASA's Artemis program is set to dramatically shape the future of space exploration, particularly with its ambitious goal of establishing a sustainable human presence on the Moon and laying the groundwork for future missions to Mars. As we look ahead, several key predictions can be made regarding the program's trajectory and its wider implications for space exploration.
1. Sustainable lunar presence by 2030. By the end of the decade, NASA aims to create a sustainable human presence on the Moon.
This will involve the establishment of lunar habitats where astronauts can live and work for extended periods. These habitats will support scientific research, resource utilization, and technology testing necessary for Mars missions. The Lunar Gateway, an international space station orbiting the Moon, will play a crucial role in supporting lunar operations and facilitating crew transfers. 2. Increased international collaboration. The Artemis program emphasizes international partnerships through the Artemis Accords, which have already been signed by 50 countries. Moving forward, we can anticipate a significant increase in collaborative missions involving multiple countries, fostering a spirit of peace and cooperation in space exploration. This collaboration will not only enhance scientific discovery but also share the burden of costs and technologies needed for ambitious lunar and Martian endeavors. 3. Technological advancements. The Artemis missions will drive advancements in several critical technologies, including lunar rovers and mobility systems. Enhanced rovers will allow astronauts to explore more of the lunar surface, conducting scientific research in previously inaccessible areas. Lunar resource utilization. Technologies to extract and utilize lunar resources such as water ice will be developed. This will support life support systems and fuel production essential for longer missions and eventual Mars exploration. Next-generation spacesuits. Modernized spacesuits equipped with advanced life support and mobility features will ensure astronauts' safety and efficiency during extravehicular activities. 4. Scientific discoveries and planetary defense. The Moon is often referred to as a time capsule of the solar system, holding clues to Earth's formation and the history of our planetary system. Future Artemis missions will likely lead to significant scientific discoveries regarding lunar geology, potential resources, and solar system evolution.
Furthermore,
observations from the Moon could enhance our understanding of near-Earth objects and improve planetary defense strategies against potential asteroid threats.
5. Preparing for Mars exploration.
Artemis is more than just a lunar program, it is a stepping stone to Mars. By 2030, NASA aims to send humans to Mars, building on the knowledge and experience gained from lunar missions. The technologies and life support systems developed for Artemis will directly inform designs for Mars habitats, rovers, and mission architecture. The lessons learned from living and working on the Moon's surface will be invaluable for the longer duration missions required for Mars exploration. 6. Emergence of a lunar economy. As lunar exploration advances, there is a strong likelihood of a burgeoning lunar economy. Commercial entities are already showing interest in lunar operations, including mining, tourism, and research. By 2030, we may see the establishment of commercial lunar outposts, enabling private companies to provide services to NASA and other international partners, thereby accelerating the pace of exploration and innovation. 7. Cultural and educational impact. The Artemis program is expected to inspire a new generation of scientists, engineers, and explorers. The symbolism of landing the first woman and the first person of color on the Moon will resonate globally, encouraging diversity in STEM fields. Educational initiatives tied to Artemis missions will engage students and the public, fostering interest in space exploration and technology. 8. Ethical and regulatory frameworks. As exploration expands to the Moon and beyond, there will be increasing discussions about the ethical implications of space resource utilization and the need for regulatory frameworks to govern activities beyond Earth. The Artemis Accords will likely evolve to address these challenges. Promoting responsible exploration and the preservation of celestial bodies. Conclusion. The future outlook for NASA's Artemis program is bright and filled with possibilities. By establishing a sustainable human presence on the Moon, fostering international collaboration, advancing critical technologies, and preparing for Mars exploration, Artemis represents a transformative step in humanity's journey into space. As we approach the next decade, the implications of these missions will extend far beyond lunar exploration, shaping our understanding of the cosmos, our place within it, and the future of human civilization in space.